Hi students, I believe that you all have understood my previous class topics. I hope you all are safe back at home. Now let's start with our next topic, average velocity. We studied earlier what is velocity. I repeat, velocity is the rate of change of displacement, or it is a rate of change of distance in a given direction, because velocity is a vector quantity. It has both magnitude and direction. Okay, note the point, velocity of an object can be positive, 0 and negative. Velocity of an object can be positive, 0 and negative according to its displacement is positive, 0 or negative. Note the point, it's a very important point. Yes, velocity of an object can be 0, positive or negative. Similarly, the displacement of an object can be 0, positive and negative. Okay. So the next portion, average velocity. Average velocity means it is the arithmetic mean of initial and final velocity. Arithmetic mean means that is average velocity is equal to initial velocity plus final velocity by 2. Average velocity is the arithmetic mean, that is the average. Arithmetic mean means the average of initial and final velocities. It is the average of initial and final velocities. Okay. Unit is meter per second. I repeat, what is velocity? It is a rate of change of displacement. So what is average velocity? It is the arithmetic mean, which means it is the average of initial and final velocities. It is the average of initial and final velocities. I hope it is clear. So we have moved on to the sixth problem. It is an important problem. Okay. The odometer of a car reads 2000 km at the start of the trip and 2400 km at the end of the trip. I repeat, the odometer of a car reads 2000 km at the start of the trip and 2400 km at the end of the trip. If the trip took 8 hours, calculate the average speed of the car in kilometer per hour and meter per second. So it is clear. So what is odometer? Odometer, note that odometer, it is a measuring distance. It is the instrument used for measuring the distance traveled by a vehicle. Odometer is an instrument used for measuring distance traveled by a vehicle. I hope it is clear. Okay, at the start of the trip, the odometer shows 2000 km. Okay, then 2400 at the end of the trip, which means at the start of the trip, the odometer shows 2000 km. At the end of the trip, it shows 2400 km, which means the distance is equal to the final point, that is 2400 minus initial, which is equal to 400 km. The distance traveled by the body is 400 km. I repeat, at the start of the point, odometer shows 2000 and end of the trip it shows 2400, which means it travels 400 km. Okay, so we know that what is average speed? Average speed is equal to total distance traveled by total time taken. Average speed is equal to total distance traveled by total time taken. So which is equal to total distance is here 400 km. Okay, 400 km divided by total time taken is equal to 8 hours. That is 400 km by 8 hours, which is equal to 50 km per hour. Okay, so the question is, if the trip took 8 hours. Calculate the average speed of the car in kilometer per hour and meter per second. Okay, we get the answer in kilometer per hour, that is 50 kilometer hour. It can be converted into meter per second. Listen here. Look at the red boxed area. That is 1 kilometer per hour is equal to, that is we are going to convert 1 kilometer per hour into meter per second. That is, then 1 kilometer per hour divided by hour, that is kilometer, that is numerator is converted into meter. Okay, we are going to convert kilometer per hour into meter per second. Then 1 kilometer per hour, that is, first of all the kilometer is converted into meter, then in divided by hours is converted into seconds. We know that seconds. Okay, that is kilometer is converted into meter and hour is converted into clear. Are you okay with it? I repeat, 1 kilometer per hour is equal to, that is, we are going to convert first of all kilometer into meter and hour into seconds. Okay, that is kilometer, 1 kilometer is equal to 1000 meter, that is kilometer into, that is converting 1 kilometer into meter, this is multiplied by 1000, that is in the second step 1 into 1000. I hope it is okay. Divided by, here the denominator, that is hour, is converted into seconds. We know that 1 hour is equal to 60 minutes. Then we know that 1 minute is equal to 60 seconds. That is 1 hour is equal to 60 minutes. That 60 minutes converted into seconds, that is 60 into 60. That 60 into 60 is equal to 3600. I hope it is clear. I repeat, that is 1 kilometer per hour is equal to, that is kilometer is converted into meter and hour is converted into seconds. Okay, kilometer is converted into meter, that is multiplied by 1000. We know that 1 kilometer is equal to 1000 meter. In denominator, hour is converted into seconds. That is 1 hour is equal to 60 minutes. But we studied earlier 1 minute is equal to 60 seconds. That is 1 hour is equal to 60 minutes, that is 60 into 60, that is 6 into 6, that is equal to 3600 seconds. Okay, so we cancel the zeros, we get 5 by 18, 1 into 5 by 18. Okay, so the kilometer per 1 kilometer per hour is equal to 5 by 18 meter per second. Okay, so look at this step, that is 50 kilometer hour, that is going to be multiplied by 1000 by 3600, that is equal to 13.9 meter per second. It's a good problem. So the red boxed area, please note the red boxed area, that is 1 kilometer per hour. So in short, kilometer per hour can be converted into meter per second by multiplying 5 by 18. Okay, note the point. Kilometer per hour can be converted into meter per second by multiplying 5 by 18. Hope it is clear. That's the point. It's a good problem. So we move on to the 7th problem. Okay. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight line path. Find the average speed and average velocity of Usha. So I repeat the question. Usha swims in a 90-meter long pool. She covers 180 meter in 1 minute by swimming from one end to the other and back along the same straight line path. Find the average speed and the average velocity of Usha. We know that. What is average speed? It is the total distance by total time. What is average velocity? It is the arithmetic mean of initial and final velocities. We studied earlier, average velocity is equal to initial velocity plus final velocity by time, or the displacement by time. Okay, here Usha swims a 90-meter long pool. Look at the diagram. That is A and B. A the starting position, B the end position, other position. Okay, that is 90-meter long. The pool is 90-meter long. First of all, the Usha swims in the 90-meter towards B and back to the same straight line path, return to A. Usha swims the 90-meter pool from A to B and back to A. Okay, look at the short diagram. The total time taken, that is equal to 60 seconds. The total time taken, that is taken to 60 seconds. That is 1 minute. That is average speed is equal to total distance by total time. Listen. Usha swims A to B, that is 90 meter. Then B to A, that is 90 meter. That is 90 meter plus 90 meter, which is equal to 180 meter. Okay, the total distance is equal to 180 meter. I repeat, Usha swims A to B in 90 meter. 90 to B, Usha covers 90 meter distance. And back to A, that is B to A, that is 90 meter distance. That is total distance equal to 90 meter plus 90 meter, that is equal to 180 meter. I hope it is clear. That is the total distance equal to 180 meter. That is total time is 60 seconds. So using the equation, average speed is equal to total distance by total time. That is equal to 180 meter by 60 seconds, which is equal to cancelling. That is we get 3 meter per second. Okay, then we have to find the average velocity. So we know that what is the actual equation of average velocity? That is a average of initial and final velocities, which means average velocity is equal to initial velocity plus final velocity by tau. Here we use another equation, that is displacement by time. What is displacement? Velocity means displacement by time. Displacement is the shortest distance between 2 points. Here the direction has to be taken, not the point in velocity or the displacement. The direction has to be taken. Okay, we know that. What is displacement? Here, Usha swims A to B in 90 meter in one direction. Usha swims A to B to cover a distance of 190 meter. Cover a distance of 90 meter in one direction. And back to A, which means first she travels from A to B 90 meter, then she backs to A in 90 meter, which is the direction has to be considered. A to B 90 meter, so the total displacement is equal to as A to B, that is 90 meter, then B to A, which is equal to, that is 90 meter minus 90, which is equal to 0. That is total displacement is equal to 0. Because A to B in one direction and B to A in one direction. Sorry, A to B in one direction and opposite to A, but opposite to that direction, which means 90 minus 90 is equal to 0. But what is distance? Here, average speed is the total distance by total time. Distance is the path covered by that body. Distance is a path covered by that body. That's why A to B 90 meter, then B to A 90 meter. The total path is 90 plus 90, which is equal to 180. But here the displacement, that is the shortest distance. That is A to B in one direction 90 meter, then back to A, that is minus 90. That is direction has to be considered. That's why we give the minus. Okay, that is 90 minus 90, that is equal to 0. I hope it is clear. That is average velocity. This is equal to displacement by time. That is equal to 0 by 60, which is equal to 0 meter per second. I hope it is clear. It's a good problem. So move on to the next topic. Acceleration. So acceleration. We heard the term acceleration in so many situations. That is, in non-uniform motion. As we studied earlier, what is non-uniform motion? What is non-uniform motion? It covers unequal distance in equal intervals of time. What is uniform motion? It covers, a body covers equal distances in equal intervals of time. That's why it is called a uniform motion. A body covers equal distances in equal intervals of time. That is called a uniform motion. So what is non-uniform motion? That is, it covers, a body covers unequal distances in equal intervals of time. That is called a non-uniform motion. So listen, a non-uniform motion of an object. The velocity of the object is different at different instants. The velocity of the object keeps on changing with the time. Such motions are called accelerated motion. What is acceleration motion? What we call accelerated motion? That's why the velocity of the object keeps on changing with the time. The velocity of the object keeps on changing with the time. For example, a vehicle while going from one position to another on a road moves with the different velocities at different instants. So it is called accelerated motion. I repeat the example. A vehicle while going from one position to another on a road moves with the different velocities at different instants. So it is called accelerated motion. So in short, note the point. In an accelerated motion, if the change in velocity of an object in each unit of time is constant. I repeat, the change in velocity of an object in each unit of time is constant. The object is said to be moving with the constant acceleration. Okay, so what is constant acceleration? The change in velocity of an object in each unit of time is constant. The object is said to be moving with the constant acceleration. So it is otherwise called a uniformly accelerated motion. Yes, that is uniformly accelerated motion or constant accelerated motion. Okay. So what is uniform accelerated motion? That is, underline that statement. The object is said to be moving with a constant acceleration, which means change in velocity of an object in each unit of time is constant. Okay, I hope it is clear. So, what is acceleration? So the acceleration is the rate of change of velocity. What is acceleration? Rate of change of velocity. That is, acceleration is equal to, look at the slide, that is change in velocity by time taken. The unit is meter per second square. The unit is meter per second square. That is change in velocity means, what is change in velocity? Final velocity minus initial velocity. So here, initial velocity can be taken as u and final velocity can be taken as v. That is, acceleration A is equal to v minus u by t. That is change in velocity by time taken. That is, t is the time taken. So acceleration is a vector quantity. Why it is called vector? So it is a rate of change of velocity. Velocity is a vector quantity. So that's why acceleration is also a vector quantity. It is clear? Okay, I repeat. Sorry. Then what is uniform acceleration? I said earlier, that is, a body has in uniform acceleration if it travels in a straight line and its velocity changes by equal amounts in equal intervals of time. What is uniform acceleration? Yes, if it travels in a straight line and its velocity changes by equal amounts in equal intervals of time. We studied earlier. We see another definition. What is another definition? The velocity of an object in each unit of time is constant. the velocity change. Okay, so what is non-uniform acceleration? Yes, what is non-uniform acceleration? Is if its body's velocity changes by unequal amounts in equal intervals of time. So what is non-uniform acceleration? Is if its velocity changes by unequal amounts in equal intervals of time. That's underline that statement. Unequal amounts by equal intervals of time. Velocity changes by unequal amounts by in equal intervals of time. I hope it is clear. Acceleration. Okay, the next one is the retardation. So what is retardation? Retardation, a body is said to be retarded if its velocity is decreasing. A body is said to be retarded if its velocity is. Retardation means negative acceleration. The velocity is decreasing. The velocity of a body decreases. The acceleration is said to be negative acceleration. That is retardation. Okay, when the velocity of a body decreases, the acceleration is said to be retardation. For example, a train is said to be retarded. A train is said to be retarded when it slows down on reaching a station. When a train is said to be retarded when it slows down on reaching a station, that is the velocity decreases. Okay, retardation, acceleration. Retardation is acceleration with the negative sign. That's all. Okay, its velocity is decreasing. Okay, so we are move on to the 8th problem. Okay, this problem will clear the concept of acceleration, retardation. Okay, so starting from a stationary position, Nickel paddle his bicycle to attain a velocity of 6 meter per second in 30 seconds. Change that is 30 seconds, that not 30 meter per second. Change this. I repeat, is starting from a stationary position. Nickel paddle his bicycle to attain a velocity of 6 meter per second in 30 meter per second. 30 seconds. Change that. That is no, it is not 30 meter per second. It is 30 seconds. Then he applies brakes such that the velocity of the bicycle comes down to 4 meter per second in the next 5 seconds. I repeat, in the first 30 seconds, the velocity is 6 meter per second. In the next 5 seconds, the velocity comes down to 4 meter per second. Okay, calculate the acceleration of the bicycle in both the cases. It's a simple question. So considering two cases, listen that. So what is acceleration? It is a rate of change of velocity. That is change in velocity by time. So look at the figure. It will help you to understand this problem. That is 3 positions A, B, Z. In starting, we know that starting from stationary position, Nickel paddle his bicycle. That is starting from A, velocity is 0. That is initial velocity is 0. So it travels with a velocity of 6 meter per second in 30 seconds. So after 30 seconds, it reaches B. So the velocity is 6 meter per second. I repeat, initially the cycle was at rest at the velocity is 0. Then it travels with a velocity of 6 meter per second in 30 seconds. That is, after 30 seconds it reaches B. That is, to calculate the first acceleration, the first case, initial velocity is 0, that is u is equal to 0. Final velocity v is equal to 6 meter per second. So we know that. Calculate the acceleration, that is first case acceleration a1 is equal to v minus u by t. We know that change in velocity. What is v? V is the final velocity. First case, we are considering the first case. So v is the final velocity and u is the initial velocity, that is v minus u by t, that is equal to initial velocity is 0 and final velocity is 6. That is 6 minus 0 by 30 seconds time. That is equal to 6 by 13, which is equal to 0.2. Okay, I hope it is clear. So the next acceleration, after we are considering the second case, only this region. Now the body is at B. Its velocity is 6 meter per second. After 5 seconds, it reaches C with a velocity of 4 meter per second, which downs. Velocity is decreasing. Okay. In the second case, initial velocity is taken as 6 meter per second. Okay. I hope it is clear. In the second case, initial velocity is 6 meter per second. Why? Yes, in the second case, its starting point is B. Okay. And the final velocity become 4. I hope it is clear. That is v is equal to 6 meter per second. In the second case, in B to C, the initial velocity is 6 meter per second and the final velocity is 4 meter per second. So we apply on the equation, that is v1, that is a final velocity, minus v, the initial velocity of the second case, by t. That is 4 minus 6 by 5, that is equal to minus 2 by 5, that is equal to minus 0.4. The negative sign shows it is retardation. That's why velocity is decreasing. 6 meter velocity decreases from 6 meter per second to 4 meter per second. I hope it is clear. Thank you.